Alright guys, so this is the second part of the graphic organizer. So this is, we're now moving on to special inscribed angles. So we're going to go ahead and start with this one. So we have two angles with the same arc. So in this case, this is a diagram. Both angles have a vertex on the circle. So we're going to be looking at this vertex and this vertex. They have sides that are chords of the same circle. So this is the side, this is the side, and then I'm going to go ahead and choose a different color just so you can see the difference. And then here is one side for this one, this angle, and then this is the other side, but they're both within the same circle. They have a measure that is equal to 1/2 of the intercepted arc. So this is still a inscribed angle, right? And so what's important here is that for this particular angle, for both of the angles here, actually the chord still pertains to both of these. So for this one, the angle is equal to 1/2 of this arc. For this angle, the measure is equal to 1/2 of this arc as well, of CD, which is actually pretty cool, I think. So now the relation to each other is that two inscribed angles intercepting the same arc are congruent. So here, measurement of angle, or the angle CAD, so what's in black, CAD, is congruent to CBD. So let's go ahead and note that this angle is congruent to that angle. Okay, so let's go ahead and move on to the first set of examples. So they're telling us to find x for each circle. Okay, so for this circle, I know that they're both measures are going to be the same. So let's see. So I'm going to go ahead and do 2x. Oh, this one doesn't work very well. Let's try another one. 2x equals 1/2 of 104. So 1/2 of 104 is 52. So I'm just going to go ahead and erase this and write 52. Okay. Now I'm going to divide both sides by 2 and I get x equals, let's see. Let's do it quickly here. 2, 4, 1, 2, 6. So x equals 26. And there you go. This is the first example. Okay, not too bad. Let's go ahead and try the next one. So here we actually don't know what the arc is, but we do know they do give us the two angles here, and we know that they are congruent. So I'm going to go ahead and set them equal to each other. So 2x plus 16 equals 4x minus 12. I'm going to go ahead and add 12 to both sides, and then I'm going to subtract 2 from both sides. So let's go ahead and when I add the 2x or subtract the 2x over, I get 2x here. When I add the 12 over here, I get 28. So then now x equals 14. Okay. Not too bad, right? So far I think those are pretty easy. Now we're going to go ahead and move on to the inscribed in a semicircle. So this is an inscribed in a semicircle angle. So the properties are, an angle inscribed in a semicircle is a right angle. So this is the right angle here. The measurement of angle CAD is equal to 90. And then they give us these things to keep in mind. The two acute angles formed are complementary. Remember, complementary means that their sum is equal to their sum equals to 90. And then measurement of angle ACD, that's this one here, plus measurement of angle ADC equals 90. So they just gave it to us in two different forms, in word form and in an equation form. So here, find x for each circle. So remember, this is, again, it is a semicircle. So this angle here equals 90. So I'm going to go ahead and set this equal to 90. So I have 9x minus 9 equals 90. I'm going to go ahead and add 9 to both sides. I get 9x equals 99. And I get x equals 11. Okay. Now we're going to go ahead and move on to the next one. That was pretty easy. I like that one. This one now, okay, so we know that this angle B is equal to 90, and I know that these two angles are complementary, which means that their sum is equal to 90, right from this information. So I'm going to go ahead and add them up and set them equal to 90. I'm going to go ahead and erase this just so that I have enough space. Okay, let's do that right over here. So I'm going to go ahead and do 11x plus 32 plus 7x minus 14 equals 90. I'm going to go ahead and add these two, combine these two. So 11x plus 7x is 18x. 32 minus 14, that is... that's 18 equals 90. Subtract 18 from both sides, and I get 18x equals 72. And then I'm going to go ahead and leave that as a fraction form. So actually, you know what? 18, I'm trying to do this mentally here. I believe 18 times 4, there we go. 18 times 4 is 72. So x equals 4. See, hopefully you would be having your calculator here at this point, but I'm doing it mentally, so let's see. And there you go. That's the two set of examples for each problem. Again, what we did today, we reviewed the central angles, their definitions, the equations. We did some examples here. We went over the inscribed angles. And then finally we moved on to two angles with the same arc. And we found out that they were congruent to each other and that their intercepted arc is the same for both of these angles. And then the last thing we reviewed was the inscribed in a semicircle angle, and that tells us that this angle here is equal to 90. The sum of these two equals to 90 as well. And then if you notice, they didn't actually tell us this, but so this is always the diameter here. It forms a diameter, and we know obviously this part that it's a semicircle. Okay, so we found out really neat information and really cool properties of each of them. So hopefully you enjoyed this lesson, and I'll see you next time. Bye.